Thanks, Margo.
Copy these all out of the book.
Sure.
Alex Bertram didn't give
Okay.
me my pencil back.
Perpendicular lines. We're going to talk about rules for perpendicular lines today. What does perpendicular mean?
The intersection.
Degrees. Okay, they intersect, two lines that intersect to form 90-degree angles, yes, right angles, perpendicular, okay? Perpendicular lines and right angles theorem is the first one, and I will scroll down to get us more. If two lines are perpendicular, then they intersect to four right angles. Meaning, if M is perpendicular to N, that's what that sign means, that like upside down T. If M is perpendicular to N, then angle A, angle B, angle C, and angle D are right angles. Cool?
Yep.
That's pretty self-explanatory.
All of these are self-explanatory.
Oh, good. Then you should never do anything wrong. Okay.
About that.
Lines perpendicular to a transversal theorem. What's a transversal?
A line that has through two parallel lines.
Good. A line that passes through two parallel lines. If two lines in a plane are perpendicular to the same line, then they are parallel. Okay? If two lines that pass through a plane are perpendicular to the same line, then those lines are parallel. It's another way to prove that lines are parallel, which then allows me to do more off of that, yes? So if two lines are perpendicular to the same transversal, to the same line, then those two lines become parallel. Meaning that I can do a lot of fun things with alternate interior, alternate exterior, consecutive, blah, 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 blah.
Fun for you.
Okay, then we have a transversal, perpendicular transversal theorem, okay? This was lines perpendicular to a transversal. This is perpendicular transversals theorem. If a transversal is perpendicular to one of a pair of parallel lines, then it is perpendicular to the other parallel line. So if you have a line that is a transversal through two lines that are marked parallel, and it is perpendicular to one of those, then it's perpendicular to the other. So this is the opposite of the one above.
You just say if a line is perpendicular to parallel lines, then it's perpendicular. There one parallel line is perpendicular.
Yeah, you can say that.
What'd you get on the left one?
96. What'd you get?
Remember, I take explanations as reasons, I take the actual theorem name as a reason, I take definitions as reasons. I take a lot of things as reasons, okay?
So I can.
I got a 37.5. I got a
I
38.
got a 48.
Guys, stop, this is math, focus, okay?
I'm just drawing pictures. I don't have definitions when I get.
That's fine, that's a good idea.
I don't have pictures.
How are we doing? I'll give you about 20 more seconds.
For the perpendicular transversal theorem.
Yep. Okay.
just need to draw-
So if M is perpendicular to X and X is parallel to Y, then M is perpendicular to Y. Okay. If M is perpendicular to Y and X is parallel to Y, then M is perpendicular to X. That's how I can figure it out. Okay. Now, Chloe, if two lines are parallel to each other and a line cuts through both of them,
It's just that, but flipped.
yes.
Okay, I get it.
Okay. You're okay. Applying the perpendicular theorems. Prove that O is perpendicular to M.
Where's oh no.
Because
Prove that
Because
O,
N and O
no,
are
no, 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 no,
right
you are doing a
perpendicular.
proof for this.
The lines perpendicular to
No, 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 no,
Yeah, it
you
is.
are doing a proof for this.
you just write it down.
Statements, reasons.
Yeah, that's too much.
What's your given?
N and P are perpendicular.
That N and P are perpendicular?
Wait, right?
Yes.
they're 90 degrees.
That M and M are parallel,
They're both 90
and O
degrees.
and P are parallel.
That M
Time
and
out,
O
I
perpendicular.
don't see anything, first of all,
Oh, never mind.
time out. I see nothing that tells me anything about things being parallel.
I know.
So that's definitely no.
N and P
I
are
know.
right.
What?
It's the angle N and angle O are right. And angle NO is a right angle.
Angle NO
No.
is right angle.
Yes.
What else?
NP.
Angle
No problem. Yep.
NP is a right angle.
MP.
M,
Angle N and
This one
P
is
is
perpendicular.
right angle.
also NP.
Yeah.
I was saying this. That's not even right.
Rigged.
Right. Sorry. Okay, those are all givens, yes?
No.
See.
Okay, now what do we do from there?
Then you say, O, perpendicular to M because of the line perpendicular to a transversal theorem, and you're done.
No, you gotta say that.
What?
Angle NO and angle NP are congruent.
Yes, sir, came in.
What?
No, sir.
And why, our congruent, definition of congruency?
Yeah.
Okay, what else?
MP and NP. MP and NP. MP
Time out.
and NP.
Time out. We're trying to prove that O is perpendicular to M, correct?
Duh.
And we know that the rule says that if two lines that are parallel to each other are perpendicular, then they're perpendicular to the same line that cuts through them, correct? Okay. So you told me everything so far, but now you have to somehow get in there that those two lines, that O and P are parallel to each other. Somehow you have to get that in there. No, you didn't. Where is that up there?
No, I was telling Alex.
Oh.
That's what I was
Okay, so tell, what did you say?
No, he said, can't you just use this? And I said, that's what I said. But you told me I was wrong.
I have to somehow state that those two lines are parallel to each other so that I can then state because line
Do you
O
have
is
to use
perpendicular.
Alternate interior.
I don't know.
Yeah,
What?
that's what I
I
was
don't know what
thinking.
it's called, but since the N runs through it, and then those are right.
Co-planar, skew.
Is it one of
You can
these
use-
that we just learned?
You could use,
you use
you
the
could
alternate
use one of
interior?
those we just learned. You also could use something else that we talked about the other, earlier.
I have a question, is that symbol between O and M being perpendicular?
Mhm.
It's not interior.
Yeah, you could use something we just learned,
Corresponding-
or you could use something else.
Corresponding angles postulate.
A what?
Converse. Converse. Corresponding angles postulate converse.
Okay, to say what?
To say that
They're parallel.
angle MP and angle NP are congruent or something.
Parallel.
And then that
No,
makes the line
no, no,
parallel
no.
because it's a
No,
converse.
no.
Yes, converse meet is proving it's parallel, right?
Yeah.
Yes, but you're not listening to me. You're picking the wrong things. Yes.
Because angle N, O and NP are congruent, O and P are parallel.
Okay.
What are we trying to prove that's parallel?
Okay, so here's the deal. Let's state that a little less messy, okay? Instead of saying angle NO and angle NP, let's say line O is parallel to line P, and then use your reason.
Because angle NO and NP are congruent.
Line O is parallel to line P, not because of that,
Corresponding angle postulate?
yeah, converse,
Yeah,
converse,
Yeah.
So what I said. But with different
but with
things?
different things, yes. You had the
I thought it
right
had to do with
you had the
angles.
right reason, it is the angles. The angles
That's
prove,
line.
yes. When we use the converse, it proves that the lines are parallel,
What is angles in the name?
Because it's about.
Just
because it's the opposite, it's the reverse. Yeah. So when you are proving that lines are parallel, you use the converse of the
Yeah.
angles theorem. That's why.
And then we're gonna prove that they are
Postulate.
congruent, right?
They use the
What?
theorem,
Is it
use
angle
postulates.
is a postulate?
No, if it's angles, you use the
Theorem.
corresponding angles theorem,
Yeah, theorem.
just not the converse
So
part.
do you have to do that with M and M then?
So now, I know that O and P are parallel, correct?
Uh-huh.
Now I need to state something like, oh, M is perpendicular to,
P.
yeah, why?
Because of the line perpendicular to transversal theorem.
So
No.
not an angle.
No, you guys are making that way more difficult than you
The
be.
perpendicular postulate.
Definition of perpendicular, anything like that would work?
90 degrees.
Definition of perpendicular.
Because
Perpendicular lines. Postulate.
Definition
There-
of.
is there a-
time out.
What is
Corresponding. You said, what did you just say?
Perpendicular lines. Postulate.
There is no perpendicular lines postulate.
Yeah, perpendicular postulate.
There's a perpendicular lines and right angles theorem that we just talked
Theorem,
about.
that theorem. You mean, I think that there is a
Perpendicular
Perpendicular postulate.
Okay, or definition of perpendicular,
Wait,
but
no,
there's not a
hold on.
perpendicular theorems, perpendicular lines postulate.
No, it's just perpendicular postulate.
Yeah.
Given a point,
Okay.
it's not a line, there's just one line.
So perpendicular postulate, not perpendicular lines
That's the
postulate.
pot line.
Somebody did.
Okay.
Okay, now, step 5, what are we gonna say?
There's 5 steps out.
Oh, dear.
Line perpendicular to transversal theorem.
Yeah, so O is perpendicular to P, why?
Because of line perpendicular to transversal theorem.
Line perpendicular to transversal theorem.
We're trying to prove O is perpendicular to M.
How about
Oh,
perpendicular?
cannot be perpendicular.
Time out. We are proving O is perpendicular to M.
That's what I was
Oh,
gonna say.
sorry.
Yeah, O cannot.
So O is perpendicular to M because of what?
The
line perpendicular to transversal.
It's because of,
Perpendicular to transversal theorem?
yes, because that's what proves that two lines, right? I'm getting
If a
confused.
line is
No.
perpendicular to one parallel line, then it's perpendicular to both. That's the perpendicular transversal. Line perpendicular to transversal is if two lines are perpendicular to the same line, they are parallel.
I never
I
did.
have no
If
clue
M
what
and
she,
P-
time,
Repeat that?
time.
I just said exactly what you said in
Time.
the slide before. Except a little different.
Oh, shoot.
Right. So the one says, if
Correct.
two lines in a plane are perpendicular to the same line, then they are parallel to one another. That's the lines perpendicular to a transversal theorem. That's not what we're trying to prove. We're not trying to prove that they're parallel. We're trying to prove that they are perpendicular. So we need to use perpendicular transversal theorem.
Yeah.
If a transversal is perpendicular to one of a pair of parallel lines, then it is perpendicular to both of them. So perpendicular transversal theorem,
I'm really hungry.
okay?
I need to eat.
Tienes mucho hambre.
Now,
Muy, not bien.
I'll have to do that.
It's no big
No
no
bueno.
bueno.
It's no bueno.
Don't tell me what to do.
You're gonna do about it.
okay, let's see something. Let me give you a picture. I'm hearing away from the slide for a second.
So we don't need to write this down?
I can supply Abby.
I'm gonna ask you a question.
They say shot in Spanish.
Shut up,
Well, you wanna say shot in Spanish?
Guys, stop talking. I bet you we could learn a lot better in here if you would actually focus. It's just a thought. Okay, pretend like that's perfect, because I'm not a good artist. Is P parallel to Q?
No.
No. Yes. No. Yes.
No, yes,
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 yes.
yes.
Why?
Because.
Because it
Right.
is.
There's four right.
Why?
Other, what's the word? It was, no, consecutive line thing, because they're both right angles, and they have to equal up to 180, and that's gonna give you the parallel lines.
Yeah.
I forget what it's specifically called.
Okay. You can do it that way, that,
Consecutive.
not interior.
It's just
Right there,
consecutive
that's
line.
interior.
It's
and
corresponding.
square.
Yeah, but it's not called interior consecutive. If you're
It's
using
called
con-
Corresponding
consecutive.
angles.
It's corresponding, yes.
Corresponding
It's
angles
consecutive.
postulate converse.
if they're both inside back to back, they're not corresponding.
It's
They're
consecutive
Yeah,
because they're the same sector.
Consecutive interior angles converse.
That's what I remember.
But let's talk about today's lesson. How can I know that they're Parallel.
Perpendicular lines.
No, that's it's the other one. It's the one where like, it's where you,
No, no. It's perpendicular lines.
lines perpendicular to
thing is,
Does
I
that
can't.
prove that they're perpendicular, or does that prove that they're parallel?
Parallel.
And I'm asking, if they're parallel, so yes, line's perpendicular
Line's
to the transversal
perpendicular.
there.
It's consecutive.
Now, is line P perpendicular to line R?
No. Yes. Oh wait,
Yes.
perpendicular. I was like,
Yes, it is.
So-
Those are-
Why?
Because.
Right angles.
You can see it.
Use a theorem from today.
Because
Okay,
math.
Okay.
Because
Because the
lines
line's
are
perpendicular to
perpendicular.
a transversal theorem.
Stop.
Perpendicular.
If you use the word lines in there, this is what I'm trying to prove to you. If you say lines perpendicular to a transversal theorem, that means you're proving lines are parallel to each other. If you use perpendicular transversal theorem, that means you're proving they're perpendicular to each other. So perpendicular only has the word perpendicular in it. Lines perpendicular means that they are parallel.
Okay, well then.
You have to get those straight in your head. This is probably the most confusing one, because they're very similar, okay?
Then perpendicular transversal.
So then perpendicular transversal theorem.
Although
So if you're
it's
trying to
confusing,
prove that a line is perpendicular to another line, okay, with a transversal cut through it, it's perpendicular transversal theorem. If you're trying to prove they're parallel, it's lines perpendicular transversal theorem. Okay? Extra word when they're parallel. Extra word, 2 words when they're parallel, because there's 2 L's in parallel. Perpendicular when it's just perpendicular.
Yeah.
Okay? That you've got to get through your head. Okay? I'm trying to be a
It
jerk
is
right now.
inside here.
Okay, now let's talk about some other stuff. Instructions.
Uh-uh.
Hence why you need, what is this lovely?
Uh-uh.
We construct a perpendicular bisector. Guys, remember we practiced this? I gave you a paper before and I said I want us to practice perpendicular bisectors. You did really well on it.
Yeah, I didn't like it.
Okay, well, you're gonna have some on your
I
homework
have
again
3
tonight.
chapters left in my book.
We construct a perpendicular bisector. A perpendicular line that divides a line segment in half, right? When you have a perpendicular bisector, it divides the line into equal parts with a 90-degree angle, okay? To do so, we do 2 things at the same time. First, we construct a line perpendicular to our original line using a compass and a straight edge. If you do not use a compass and a straight edge together, you will not do this properly.
Oh, so I need to go get mine.
You said to get this.
Mine's at home.
You said to get this.
That
You
is
said-
what that is.
I'll pay.
This is a compass.
I left mine at home.
Do them all.
Okay? Number 2, we bisect or divide into 2 equal parts the line segment defined by the 2 points on the line in the first step. So construct a perpendicular line with a compass. Start with 2 points on a line. So we're going to practice this. You just need to, on your paper, use a straight edge. I'm going to practice it on the board. It won't be as pretty as yours. I want you to start by drawing a line. Doesn't matter what size it is. And then put 2 points on that line. Okay? Well, that's gonna be hard for you. Okay? Now, we are going to open up our compass. Okay? And you are going to draw an arc. You're going to keep the compass wider than the distance halfway between the points. Meaning, I come here and I make my distance wider than what would be halfway between these points.
Oh, I remember.
Got it?
Oh, I remember this.
Yeah. I'm
I can make my own.
I'm refreshing you. And you make your arc. Yes? Okay, which on my whiteboard, remember, it's really crummy because, oh, and this marker is dried out. That's nice. Well, I'm gonna make it like this because I can see where I drew it. No. Okay, and then you keep that same length that you had, right? And you flip it to the other side and make your arc. Okay?
Dude, this ain't working.
Yes? Remember that?
Yeah.
And then you take your straight edge, right?
And you draw it in the middle.
And you draw it down the middle, and you have your perpendicular bisector. Remember this?
Yes.
You're gonna pretend that mine's perfect because I'm on a whiteboard and I'm
Sure.
gonna make it
So
look perfect.
perfect.
Beautiful, I know, thank you.
I got you.
I'm so good.
I listen to Backstreet Boys Christmas album.
It's because they're back.
Yeah.
Okay? So, do not forget, we are gonna do that on our homework tonight, okay? That's what these instructions all are. Now, let's talk about drawing parallel lines. Did we do that before? Do you remember the rules we just went over?
Yeah.
If you draw a perpendicular bisector through something, and you wanna make a parallel line to that, what does that mean? Let's say I have this line right here, right? I already drew my perpendicular bisector through it. I can draw another line that is parallel to this one, as long as that bisector goes through the same thing, right? And it's perpendicular to it, okay? So, to draw a line that's parallel, okay, place your compass at a point and draw an arc through a line. So we're gonna draw a new line, just to have some fun. So if I draw a new line,
I'm just gonna pretend like I
okay, I'm gonna place my compass at a point off of that line, it doesn't matter.
Just don't do it without him.
Let's say this is where my point is, okay? And I'm going to take my compass, and I'm going to draw another arc again, okay? Kelly, you okay?
Yeah. I'm just pretending to do it.
You're pretending to do it?
Yeah, see, I did it right here, but without a compass.
Place a compass at a point, draw an arc through the line. So I'm taking this, and I'm just drawing an arc through this line, okay? Where it crosses, you're gonna put 2 points, because it should cross through there, yes? When you use your compass.
Or what if my line's a little weak?
Well, that's okay. You're supposed to use a straight edge.
Oh,
Okay. From there, you're gonna make 2 intersection points. Create 2 arcs using points on the line, and you follow the same steps. So what you're doing is this. I'm going to have something that is a little bit more than halfway, and I'm going to make an arc. Boom. Okay. It's a right
And it's supposed to go through that?
And then I'm gonna make an arc over here too. Boom. It's gonna act like it's perfect when we do this, okay? And then what happens is when you line this up, they should all be in a line. Oh, actually, it turned out pretty good. Okay? And now I have a line that is going to be parallel.
Oh, wow.
Well, there's a hole in my paper.
You see how
Wait,
that-
did you keep it the same size?
Couldn't you just like draw? a
No, you
line?
don't have to keep it the same size. Nope, you have to show me with
Look how
construction
pretty
marks. Thank you. Appreciate it.
Clearly some construction marks.
I would just be the one person to see that dad just draw a line. Not even
Appreciate your participation.
Oh, sorry.
Yeah.
Sorry,
Okay.
sorry, I felt.
And that's what we're looking at doing when we're constructing. So tonight on your homework, you're gonna have to show me construction marks on some of these problems. Coolio?
Okay.
Not
What are construction marks? Coolio.
Like
The
the arcs.
Oh.
Okay? So when you draw your line perpendicular, Kaden, through that point,
We're just.
you draw it past that
Yeah.
point, and then you come down here and you create your your parallel line.
I like it.
Because now this is perpendicular to the
Oh, I got you. Yeah, I
Makes
got you.
sense?
Yeah. I'm gonna
Okay.
give you a high five.
Fast.
Okay, last part, distance and perpendicular
Oh, no.
lines, okay? This says draw a perpendicular segment, vertical segment, is perpendicular to horizontal line. What is the distance between the point and the line? How can you figure out distance?
Four, it's
Radical.
The what, Courtney?
Distance formula.
And what is the distance formula?
Radical
X
plus
plus
one.
one.
Plus x.
X1.
Plus
Sorry, X plus
X sub
X2
squared
minus
y sub 1 plus y sub 2.
Okay, so if I know, if I know that this point right here is at 2, -1, right? Because I can read a graph. Okay, I've got to figure out a point that's perpendicular to it, correct? So if they don't give it to you, you've got to create a perpendicular bisector through it. If they do give it to you, where on a graph where I can read it, I just need to line it up, and this would be at 2, 3,
They
yes?
usually give us that though.
Right, I'm just telling you, it's not.
Okay.
So then you take the square root, right?
Yeah, and you do.
2 minus 2 squared plus. So I get
You did it opposite.
0, 4,
Minus.
0,
I
But it's
so
plus,
just-
so kind of. Oh,
0.
Way to go, Courtney! Snaps for Courtney. Let's step it up.
4, 4.
Why somebody else snap?
Are you sure it's minus? I don't
Good job.
think so, I think that's wrong. Should it be,
I said
No.
No, it's
definitely
minus.
X1
It's
X1
minus
minus
X2
and
plus.
this is plus?
Yeah, that's
what
not
I
plus.
said.
Yeah, yeah.
You'd be like squaring such big numbers.
Yeah, because that would be crazy.
Disappointed.
Okay.
Disappointed.
Sad snaps. Okay, so that's what it is. It is minus. So it's 2 minus 2 squared plus 3 minus
Whoa.
negative 1 squared, right? So it's gonna give you the square root of 4 squared. So it's gonna give you 4, yes?
No.
Now listen, when it gives you a graph, I don't wanna see you count those little spaces. I wanna see the work behind it.
I don't want to do the
Plus
work
one,
today.
plus
I
two.
don't want to do the work
Okay.
today.
I knew the answer.
Show me the work, period. Because later on, when you are in Mr. Rice's pre-calc class, you better show work.
Guess what happened today?